Here we go. All right, cool. So, ready. So, again, thank you all for coming. This is going to be talking about machine learning in AWS. So, who here has actually used the cloud for anything, whether in production or for playing around? Okay, cool. Keep your hand up if you have used AWS and are doing anything in production in AWS. Doing machine learning in production in AWS. All right, cool. So we got a few hands. So I'll have some support here in case I say anything wrong. So that's good. So I know in the description of the page, I talked a lot about like operationalizing machine learning. I want to clarify a little bit what I mean by kind of what I'm talking about today, at least. I'm talking really more about the training of the models. There's a lot of options for serving and scoring models via APIs or offline scoring. That's not something that I personally have gotten to yet, so I'm not going to be able to speak to too much on that. But this is really more about just being able to tinker with stuff, play with stuff, launch up instances that are bigger than your laptop to be able to play around with it. Okay, I have an About Me slide first. So that's me. Danny already gave a good intro on that. Quick little plug. My company I work for is Modernizing Medicine. We're a healthcare software company. We do electronic medical records. And we've grown to about 600 people in the last 7 years, hiring 800 more in the next 5 years. So if anybody wants a job, go on that page. We're hiring all kinds of engineers. We really need a data engineer right now for my team. We're hiring. I'm sorry? Oh, I'm a data scientist. Data scientist, but I do a lot of data engineering as well. I've had to use Amazon for a lot of this stuff. We're hiring iOS engineers, Java engineers, QA, a bunch of non-engineering jobs too. So if you need anything, talk to me after though if you are interested in being a data engineer because we need that like stat. So quick agenda. We'll talk about the cloud, like I said. I did say in the description of the meetup that we'll do a lot of operationalizing stuff. And as I was preparing for the talk, I was realizing that a lot of background knowledge kind of has to be developed in AWS and just a lot of the random concepts and acronyms and stuff you have to deal with. So we'll start off in the GUI. So we'll start off with the Amazon console and just being able to click around on launch of instances and then launch a Jupyter notebook just to be able to play around with stuff. And then based on kind of the time that we have, we'll dive into this little package that I've written to kind of operationalize and make some of these experiments easy to run. So we'll get to it. Most of this should be kind of walking through Amazon and looking at some code, so I don't have too many slides. So I have one slide on the cloud, and this is it. So we have this. Our cloud services or DevOps team has this picture in their office, and I like it because that's exactly what the cloud is. It's not something magical. It's not something that's really changed anything. The real big thing about the cloud was that Amazon had all of these servers everywhere, and they realized that we have all of these servers to support their own business, but they realized there was so much unused capacity on them, so why not lease that out to people who need hardware? So that's really what the cloud is. It's just you're leasing somebody else's computer.
Or 10,000 computers.
Or 10,000 computers.
On your own.
And that's the benefit. And so I did lie. I actually have more than one slide on the cloud. But that's the only one you need to remember. This is exactly what you're saying is a few points about why you would even need to use the cloud for anybody who hasn't. Ease of use, first of all, you don't have to deal with hardware. I started off life doing hardware, the whole A+ certification and PCs and pulling out video cards and all this stuff. And as soon as I bought a Mac, I didn't want to do any of that. So this makes it really easy where you don't have to deal with any hardware. Scalability, you can launch up instances way, way, way bigger than anything you'll be able to get on your laptop or even at home, and you can get a bunch of them. You can get hundreds of CPUs, hundreds of gigs of memory, and you only have to pay for them when you use them. And fun little fact, preparing for this talk, I launched up all kinds of instances. I launched up some instances with like 60 gigs of RAM, like 16 cores. I launched stuff with GPUs, and I left stuff on, and I played with it. And I just checked my bill before this, and I only spent $1.50. So a lot cheaper than going out and buying some hardware. Yes, please, and for my future experience. So quick little kind of drive this point home a little bit. What's really interesting with deep learning and kind of the revolution, if you want to call it that we've been seeing these days, everybody needs a GPU now because you need a GPU to do these intense deep learning computations. And the trend that we've seen for years and years in hardware is that, hardware always gets cheaper, right? It's cheaper, things are going to get more RAM, things get, more CPU cycles, everything gets faster and cheaper as time goes on. But what's interesting is that GPUs are starting to get a little more expensive because of the really, really big demand for them. So this is a Tesla K80, is an NVIDIA chip. It has 24 gigs of video RAM. Like 5 years ago, who thought there would be that much RAM in a video card? I mean, I'm not even that old, and I still, makes me, boggles my mind. So I remember when my card had 1 gig of video RAM, and it was, amazing. So remember that number, $2,700, right? Same instance with AWS, right? GPU, 60 gigs of RAM, 90 cents per hour. So unless you're going to have it on 24/7, 7 days a week, much, much cheaper to do it on Amazon. And this is just the on-demand price. You can get it even cheaper with spot instances, as we'll talk about. So I hope that kind of drives the point home if anybody is considering using the cloud. And there's all kinds of security considerations that I won't go into, but your stuff is pretty safe, I think at least. So any questions just in general, cloud computing, before I start diving into the concepts that we need to kind of get going on Amazon? Cool. All right. So there are 3 services. Amazon AWS has all kinds of services, and there's dozens and dozens of things to do whatever you need to. What we're going to be doing is more of the low-level stuff. So basically, just getting a machine and being able to log on to it and do some stuff. There's a lot of serverless products out there now where you're able to do machine learning more as a service than kind of having to do it on your own. And that's really good for pre-packaged stuff. If you have a whole bunch of images and you know that you need to classify them in a machine learning model, you have some text that you need to do sentiment analysis on, and it's very straightforward. Nowadays, you might not even need to launch an instance. You could probably use something like Azure's machine learning, IBM Watson, Google Cloud ML. Amazon has a thing called SageMaker. And those are really good kind of service-based machine learning. But if you're coming up with your own algorithms, if you're trying to just tinker with this on your own, if you're writing some computer on your laptop and just need a little bit bigger hardware, this is really what you're going to want to do. So, like I said, 3 services. One is EC2, is Elastic Compute Cloud. One is S3, which is for storage, and then one is for identity and access management. I'm going to go back to EC2. So this is really the bulk of what you need to consider for Amazon, and this is how you get your hardware. So the kind of term that's used for the machines is an instance. So when you want a machine in Amazon, you're going to launch an instance. And there's a couple different options for pricing. So what I showed you before was the pricing sheet for an on-demand price, which basically means it's 90 cents an hour, and recently Amazon's actually switched to paying per second. So now even if you only launch it for a few minutes, you only pay for those few minutes. So Spot, however, is a way to get cheaper instances. It's again related to Amazon having some extra hardware lying around. So the background to this is, Amazon will have a rack of servers, right? Let's say on this rack there's 10 servers on it, and 9 people have requested those machines, and they're paying that 90 cents on-demand price. There's now this one extra machine kind of just sitting around, not doing anything. So rather than them losing the electricity and kind of missing out on the opportunity to sell some time on it, they'll actually offer spot pricing, which is a reduced and sometimes significantly discounted price for the instances. So I just launched one of those GPU instances, and I launched it for 40 cents an hour instead of 90 cents an hour, just because Amazon happens to have unused capacity. So the one catch to that, though, is that they can shut down your instance at any time. So if you use a spot instance, you can't guarantee that it's always going to stay up. So you have to make sure that you're saving things to S3, which is a persistent storage. You want to make sure you're checkpointing that you can recover in case your instance does go down. And we'll talk about that a little bit too. Keras has some nice checkpointing where you can actually checkpoint your model every epoch. So that's instances.
What about performance? Is the same?
Performance is the same. Yeah, same exact hardware. It's really just about the availability of it, and they'll chart you. Then you can just have a cheaper price. If you need to make sure that it's always going to stay on, you'll want to do an on-demand price. So for some of the stuff, we use on-demand just because we need it to be on 24/7. But if you're just tinkering around, or if you have like a big experiment that you're running and a couple nodes can go down, spot price is perfect. Yep.
If you're on spot and you lose connection, can you go back on immediately, or how does that?
It depends on
Is there a key?
yeah, well, it depends on availability. If your spot instance goes down and you need it right away, you can relaunch it as an on-demand. You're just going to pay a little bit more. But if you wanted to wait for the spot availability, you can wait for it, or you can actually change your bid price. So if the on-demand price is 90 cents, you have anywhere from 0 to 90 where you can actually bid. If you can increase that a little bit, maybe you'll keep your instance.
So it's like an auction, you said?
It's sort of like an auction. Like the price fluctuates based on availability. So you basically, it's kind of like eBay, right? You go in and put in your highest bid and say, if the price goes over this, shut down my instance, essentially. And there's a couple options where you can actually shut down your instance and still keep all the settings for it, which is called a stopped instance. Or you can actually let it completely disappear, and then you lose your instance and all your settings, and that's terminating. But that's a detail we don't really think about right now. All right, so that's the instances. Now, that's just hardware. The Amazon machine images are the software that you put on it. So it's related to the OS that you're going to put on it, as well as some predefined software that you want to load on there. So there's a really basic Ubuntu AMI. There's a really basic Linux AMI, I think is CentOS. But there's also some other AMIs that have prepackaged software for you. So what we're going to use today is actually a deep learning AMI that has Keras and TensorFlow and Theano and CAF and MXNet and all that stuff, where you don't have to configure anything. You don't have to install any packages because the AMI is already pre-configured for you. And there's a whole bunch of them, and you can kind of just search for the one that you want based on your use case. But that's something that you need when you're launching an instance. You need to know and pick the AMI that you're using. We're not going to go too much into storage because we're going to do all of our storage on S3, which is again a separate persistent storage from EC2. But in case you do need storage on your EC2 instances, you can attach volumes to it, and they're separate. They're priced separately from the instance, so you pay just per gig, and it's super cheap. That's in case you need it. So if you're doing any sort of like big data stuff where you do need some disk space on there, we're doing everything that we're going to do today is going to be CPU and memory bound, so we're not going to worry about ABS volumes for now. Where it gets a little complicated now is into the networking and the security, because of the fact that the cloud is somebody else's computer. It's actually a shared resource. So Amazon puts in a bunch of stuff there to make sure that you're logically separated from other people, and you can have more or less security based on what kind of configurations you want to do. So the key concepts that we're going to go through, and again, I'm going to walk through this so you don't have to remember all this stuff. And most of this stuff you set up once, and if you're just playing around, you don't really have to think about it too much. When you go into production, and if you're like using this as a business, there's definitely way more security stuff that you need to consider that I can't help you with. So don't blame me, like if anybody steals your data or something. So we're going to assume that everything here is publicly available data, and it's not really that secure at this point. So things to consider here are availability zones are basically just Amazon's data centers. So there's like an US East availability zone that's in like Virginia, and there's a US West, I think that's in Oregon. The one reason I mentioned the availability zones is that the AMIs are actually linked to availability zones. So when you search for an AMI, you just got to make sure that you're launching it in the availability zone that your AMI is in. Why that is, I have no idea, but that's just something to consider. A VPC is a virtual private cloud. And that's kind of just what it sounds like. It is shared hardware, but what Amazon does is it logically separates all of your hardware to make it look like it's just your data center. So that way people from other hardware on Amazon can't access your stuff. And then related more to networking, you launch your instance under a subnet, obviously because there's a range of IP addresses that you're going to need to get. And then security groups are related to, similar to firewalls, how you need to open up certain ports to make sure that the outside world can get to your machine. You can assign a security group and then launch instances in that group with a certain amount of settings, so that way you can get to it. Like we're going to open up port 22 to SSH. We're going to open up a couple ports to get to you from the web. And last but not least is key pairs. So when you log into your machine, you have to use a key pair from Amazon. So basically they generate a public-private key, and they give you a PEM file which has your key stored on it, and that's the only way you can log on to your instance. So nobody else can actually SSH on your instance because they don't have your key file. So you just have to remember that you don't lose that. If you do, you can make a new one, but that's something to consider as well. Any questions here? Am I going too fast?
Can you
Yeah.
Can you share that key among different people, different computers,
If you trust them, yes.
and you SSH to one host if you want?
If you want to, yeah. And you can use the same key for multiple hosts. You can separate them out. Like if you want certain people to have access to certain instances, you can give them one key, or you can give people another key. Yeah. Do you have a question?
Yeah. Since you deal with EHR, is there any limitations with HIPAA? Or
Yes, there is. So with Amazon, we have to have a BAA with Amazon. So we have to, the business associate agreement, basically something in the law telling us that you're allowed to use, basically Amazon now becomes a subcontractor of us, an extension of our company to where we can store our protected health information on there. Another thing is that we can only use HIPAA certified services from Amazon. So EC2 is one of those HIPAA certified, but some of those other ones that I mentioned might not be. So you just have to be careful using Amazon that you're only using the certified ones. But once you're on there, once you have a BAA, you're free to use it. There's obviously security things. You got to make sure all your data is encrypted at rest, encrypted in transit, and that's some of the other settings that I'm not going into, but you can definitely do it with healthcare data. Yep. Question? Certain services are, but you do have to get a BAA, so you can't just launch it and then put. I'm sure it does. I don't know exactly because I don't deal with it, as the company, but I'm sure there is some sort of price in there. Yeah.
Something else, you said something about the keys and pairs. I'm not familiar with it, but do you consider that best practice, like just giving your keys, your same keys to people that you want to SSH to that instance?
It's probably not. You can do it.
You can have multiple.
You can have multiple keys. Yeah, yeah. So you can set that up any number of ways that you want. For us, we'll have one machine, one key just for now. But again, I'm not like a security expert, so I don't know all the details. I kind of do what my DevOps team tells me to do. Any other questions? All right, so that was the complicated one. The next two are pretty straightforward. S3 is basically Amazon's blob object storage. It's just a persistent store. It's serverless. You don't have to deal with a machine to get to it. And it's just object storage. You can put files up there, and it's free to put data into S3. It does cost a little bit to move data around from Amazon service to Amazon service, and it costs even more, obviously, to pull your data out of S3. So that's how Amazon gets you, right? So like if you were to download something from your S3 bucket to your laptop, you're going to have a cost incurred there. It's not super bad unless you're downloading like terabytes of data every day, but that's just something to consider. You pay per gig, I think, and then you pay for a little bit on transfer costs. And you can set up security on those too. You can have like a public bucket. Like I have a public bucket that we're going to get our data from. You can set up different permissions and different roles where only certain people can access certain buckets or certain folders. Yeah.
So if you have multiple machines that are shuffling data between them, they charge you for that, or it's just when you get the data to your laptop?
They do charge you even if you're still in Amazon. Like if you're moving data from S3 to an EC2, they do charge you, but it's like significantly less than what it would charge to actually pull it down. I don't know off the top of my head, but it's one of those things where I don't even think about it just because it's not a huge deal. And one thing to consider with S3 is that it's not like a normal file system where you actually have folders and files. S3 is really just an object store, so even though it may look like there's a file path with folders to your particular file, each file is actually sort of indexed on its own. So each file, just like all the slashes you'll see for the folders, that's just the whole entire file's name. So there's a little bit of latency that you get when you're dealing with lots and lots of files. So if you want to recursively delete a folder, it can't just delete the folder. It actually has to go through every single object and delete everything inside of there. So shouldn't notice that today, but that's just something to consider. So the identity and access management I didn't want to talk about today, but I kind of have to because we have to set up a couple roles and users and groups and whatnot to get access to these different things. So the main concepts we're going to cover today, and it's pronounced IAM, I think, or at least that's how I pronounce it, so I'm going to go with that. The main keys are users, groups, roles, and policies. So the way to think about this is that a user is essentially as a person. So a user is somebody that's either logging into the console or setting up the command line interface on their laptop, and they are requesting instances, they're putting files to S3, they're moving stuff around, and they're doing things on your AWS account. And then groups are just permissions you can assign to multiple people if you need to share permissions. Roles are a little bit different because the way you can think about roles is actually assigning the permissions to a service. So rather than saying this user, John Doe, is going to log in, I'm going to let him create EC2 instances, what a role does is it lets an EC2 instance go do something in another part of Amazon. So what we're going to do is we're going to create a role to let our instances access our S3 bucket. So that's not something that where you're letting a person or a user access it, but you're actually letting a specific service have open access to do stuff. And then policies are just those permissions that you give it. Any questions on S3 or IAM roles and users and groups? All right, so last slide before we start to dive into some stuff. This is basically, I'm going to be referencing this slide. So these are the steps we're going to go through right now. If you don't already have an AWS account, you kind of follow along later at home. I am recording this so you can get the video if you want to look at this later. It's really easy. You kind of just put your credit card in and launch, put in a password and make it. First thing we're going to do is create an S3 bucket so we can store some data. And then we're going to set up an IAM role so that way we can create an instance that has access to that S3 bucket. We're going to launch an instance from the console, get your key file so you can SSH to it. We're going to open a couple ports up so that way we can SSH to it. And then we're going to launch a Jupyter notebook, which is a way to run some Python code and play with stuff. And that is actually going to be running on the instance, but you're able to get to it from your local web browser. Anybody not super familiar with Jupyter and the Python ecosystem or in data science want to talk about more? All right, cool. That's good because every time you go in these environments, more and more people know about Jupyter, so that's awesome. Okay. So wait, no, I have a fun slide. Oh, there we go. All right, so now we're going to try to blow some stuff up. So we'll see what happens. If you want to, I basically stole a lot of these resources from this link down here, so kind of want to give credit where credit is due. So let's get going. So I pulled up my EC2 account. Hopefully I'm not going to show anything sensitive here. This is my EC2 account. This is not Modernizing Medicines. So anything here I can just delete the user or something if I show something wrong. So first thing we're going to do, like I said, is create an S3 bucket. So is anybody following along so that way I can slow down? If not, I'm going to go a little quicker. All right, cool. It's easier if you kind of just do that at home anyway. It would take too long to do it here. All right, so first thing we're going to do is there's a million services that that you can do in Amazon. I think this is the home page. This might be the home page. I don't remember. I made my account a while ago, so I don't know what it looks like from a cold start. But anyway, this is your Amazon account. So like I said, we're going to use just 3 services. One is EC2 here, one is S3, and then one is IAM. So the first place we're going to start is S3. Oh yeah, absolutely. Sorry about that. Yeah, I totally forgot about that. There we go. Sorry about that. Okay, cool. So now this is S3, and you can see I've already made a couple buckets. One of them I made public, so that way people can download data from it. But super simple. All you got to do in here is create a bucket, put in bucket name, right, and you can set some settings. Oh, dang! Somebody already has that. Aaron's cool bucket. Oops. All right. So then you can go in and set some other crazy stuff that I don't have to deal with right now. We're gonna give me read-write access. We're not gonna make it public in this case. And so now I can review and create a bucket. So now my user can do anything I want to in Aaron's cool bucket. So we can.
So the bucket is it's permanent file storage.
Yes.
So you didn't specify your size.
No, yeah, and so actually that's one thing I should have mentioned about S3. It's virtually infinitely scalable. Virtually, right? I mean, sometimes there is some sort of limit to what Amazon has, but pretty much any data that you throw at it, it'll be able to take.
So not even for your own control can you limit I want this bucket to be 1 petabyte.
I don't know if you can do that. Does anybody know if you can do that? Limit the size of a bucket? No? Okay. I mean, what you could do is, if you do have services that are accessing the bucket, you could, have a background thing that checks the size of it and then, turns off permissions when it gets too big. but I don't know if anything out of the box where you can do that.
They limit it by the amount of money you're willing to pay.
Well, there you go. Yeah. So if your credit card declines, then your S3 will stop working.
Is any reasoning behind why you should create more than one bucket, or you should create just one big bucket and your data just grows there?
Yeah, it's a lot of it's separation. So like it's nice to have different buckets. Like what I did is I made one public bucket, one private bucket. So I know for sure that my private bucket is private. Nobody else can get to it. What we do a lot of the times too is you'll have a prod bucket and a dev bucket where you can have the same exact code, except there's just one little setting that says which bucket it's going to. So that way your dev doesn't break anything in prod.
Just be very careful. You're only allowed, they may have changed this, it was 100 buckets a while ago.
Yeah.
So you got to manage that.
Yes.
So, and you want to make sure that you never give the global key out. What you use is you go create a bucket for, say, customer set X, my big customers. They'll be in this bucket, and I'll use some identifier, a boolean or something else underneath. And that one has its own key set that nobody, that is the only one that uses. That's very important within Amazon because if you're not careful, you don't realize it, you can share a bucket out and you don't know what you did. So you got to be very careful with S3. It's great, you just got to be very careful.
Yeah, and I believe anybody can list all the buckets on S3, so don't put any sort of secure name as your bucket name. Do you have a question?
If you're going to use a database, you need a bucket or a different kind of service?
If you're using a database, the easiest thing to do with Amazon is use RDS, which is their relational database service, which it's a much more scale. Like you could request an EC2 instance and get volume on there and just install a database like you would on any other hardware. Amazon does have RDS, which basically abstracts a little bit of that hardware for you. You just pay for the size of your database and usage and things like that. Yep.
RDS, you can go and set RDS to global. So if the Eastern data center goes down, it'll pick up on one of the other data centers. So RDS is a very powerful tool, but RDS will only allow you, for example, MySQL will only allow you 40 instances of MySQL. You have to go to Amazon and ask for more instances, and they don't give that many. So it's a redundant thing. Underneath the covers, what they're doing is they're clustering and they're duplicating for you. So you just need to be very careful how you architect that into your structure. But it is it's like gold. It's wonderful. But you've got to be very careful in how you architect it.
Yeah, definitely. And if you're doing any sort of like big data stuff with Hadoop, Spark, you can use Amazon EMR, which is Elastic MapReduce, and you can actually kind of save your stuff off to S3 if you're doing it like that. Okay, so that's S3. You have your buckets and really easy. Next thing, what was my next thing? Next thing was, okay, set up an IAM role. So before we launch our instance, we want to make sure that we can launch an instance with access to this private bucket. So the way to do that is go over here to Services, back to IAM, and we're going to come back to some of this IAM stuff. So for the immediate thing we need to do to get just an instance going is we have to set up an IAM role that can access S3. So here under roles, we go ahead and create role. I already have one. If you're going to use the package that I made, make sure you name your role EC2_role just because it's hard-coded right now. If you don't like that, yeah, open a pull request. So go ahead and create a role. And so again, remember, a role is granting a service access to something. So not a person, not a user, but a service. So what we're going to say here is I want to say I want my EC2 instance. This is the service that I want to give access to. In this case, I'm just going to do all EC2. And the permissions I set up are going to be, there's all kinds of permissions that you can attach to it, but what we want right now, and this is the policies that we were talking about, right now I'm just going to give it S3 full access. So that means now it has S3 access to all of my buckets. If you wanted to, you could limit specific buckets, specific folders inside of those buckets, but for the purpose of this exercise, we're just going to create a role that has S3 access to everything. And then I'm going to call this my new role, and then you can create it. So now, when you launch an EC2 instance, you can assign this role to it. And I think that's actually the next step. Yes. Okay, cool. So the next step is to launch our EC2 instance. So back to another service, new one, EC2. here is going to be like a quick dashboard on your instances. So you can see here that here's the different availability zones. And it'll tell you you're running instances, kind of your key pairs, volumes, and whatnot. So we want an instance, click the Launch Instance button. And here, first step is the AMIs that we talked about. So if you want just like a base Linux install, this first one is super easy, just has, you know, regular Linux. Since we're doing machine learning and deep learning stuff, we can go over here to these community AMIs and just search for deep learning. This one is great because I'm going to use the Linux one because I just like CentOS better than Ubuntu. But what's great about this is that it installs all these packages for you, and it actually installs them in Python environments. So they're all distinct environments. So you can go and launch in a notebook with each PyEnv or whatever.
Where did you pick which GPU base if you want to get that high-end GPU?
Oh, that's next page. So once you select the AMI, oh, I'm sorry. Yeah.
You chose the second one. What was the difference between the first and the second?
Oh, the first one is on Ubuntu, and the second one I believe is CentOS or Red Hat. Just different operating systems. Some of the commands are a little bit different. I'm more familiar with CentOS. So.
Based on your experience, do you recommend the CentOS besides the Ubuntu? Or?
It doesn't really matter. They're both equivalent. It's just some of the commands are going to be different based on the operating systems. If you're going to follow along, I'd recommend using the Linux one just because a lot of the code that I'm showing may or may not depend on the specific commands.
I've been doing this for a while. I couldn't tell the difference between Ubuntu and CentOS. Ubuntu looks better.
Yeah.
Hey, that's important.
It is very important.
You know, some of the environments don't bring all the packages or all the standard library, so that's what I was asking.
Yeah. And so the AMI choice is more important than the operating system choice. And the one difference I can think of off the top of my head is that Ubuntu, if you want to install something, it's apt-get versus Red Hat is yum. But yeah, so the actual AMI you choose is the more important one. So what's dumb about this one is that scikit-learn doesn't come installed on it, but we can do that later.
What's the level of access that you have to the image? Like, can you install package, modify packages, update it?
Yeah, you have full access to the machine, and probably more access than people want now with those. What were those two bugs that came out with the
Spectre.
Yeah, Spectre and Meltdown. Yeah, so I think they fixed one of them, but anyway.
But if you do not, if you spin it down instead of stop it, which is just pause, which block that page still, you lose all that. So you have to be very cognizant.
Yeah, and so that's the dip with those volumes we were talking about. Like if you stop an instance, like you said, if you pause it, you keep the volume. You have to pay for the volume, but now you can spin it back up to exactly where it was. If you just terminate the instance and then now you're not paying for that storage anymore, next time you boot something up, it's a completely different instance. Like it's a new ID, completely different place, could be on a completely different server, and you don't have any of your data on there. For everything we're doing, we're going to be doing launching and terminating because everything's going to store on S3, and we'll script. Like there's a couple things you have to install at the beginning, but it's super easy to just script that. So.
But once you set up your MI, you can save it somewhere instead of.
So you
terminate when you finish your job. And
yeah. So little difference with the AMI and then the actual volume. The AMI is basically a pre-configured image, and you can make your own if you want to. But if you take somebody else's AMI, launch an instance with that AMI, make some tweaks, install some stuff, you'll want to keep your volume around, which is basically the hard drive, essentially, that it associates with it. And that you'll pay for. It's really like negligible cost. But if you want that again, you just want to pause or stop your instance, and you can then launch it again with that. Yep. But if you find yourself doing that a lot, you could make an AMI if you wanted to. So here is the instance type page, and what stinks is they don't put the pricing on here at the same time, but you just Google EC2 pricing and you can figure out what the pricing is. But there's all kinds of instances, and what's cool is if you're playing around, you can actually get one for free. It's like a tiny, tiny instance, but just a test if you're playing around with some code that's like launching instances. Like if you forget to leave this one on, it's probably just like a few pennies or per hour, so not a big deal. But we're going to go down here to the good stuff. So GPU instances. So we're going to use the P series instances because these are specifically for GPU compute. But I think, what was this? CPUs, memory, right? So Here we can see the P2X large gives you 4 CPUs and 60 gigs of RAM, and it doesn't list it here, but it gives you one Tesla K80 GPU. The P2 8X large will give you 8 GPUs, which is like crazy, and I think they limit it to like 1 per account that you can actually request. But it's cool. You can just go get it. You can pay for it on a spot price, and if you want to just like show that you have 8 GPUs running and like screenshot it and post it on Twitter or something, be like, look at me, I have 8 GPUs. I'm great. What's interesting about that though is I tried to do that. Like I had this Keras model that I was running, and I tried to run it on a multi-GPU, and it actually took a lot longer than a single GPU because of the parallelization cost. And so if you're doing a multi-GPU, you have to go like really low level. You have to go like way into TensorFlow and then really think about the model that you're building. So for all intents and purposes, this P2 8X large is perfect. Gives you a single GPU, way more than you have on your laptop.
So it's not just
Yeah. So yeah, I mean we could dive into GPUs for all night long, but we haven't even gotten to the fun part yet. So let's keep going. So once you pick your instance,
I'm sorry for bringing this.
no, it's all
I
good.
have tire marks on my back. That's all.
All good. So once you pick your instance type, we have one more page to set up a couple settings. Here is where you would request a spot instance, and it tells you kind of the current price for it. So I see right now it's tracking around 30 cents, so I'll go ahead and put it in for 40 cents an hour, a lot cheaper than the 90 cents that you would have normally gotten. I believe when you first make your Amazon account, it provisions the VPC for you. If not, you might just have to like click a button to create the VPC. I don't remember. And in this case, we do want a public IP. So as long as you don't set a non-default subnet, it'll give you a public IP address. And key thing here we want is our role. So we want the specific IAM role, so that way now this EC2 instance can do everything that I say in that role, and in our case is just accessing the S3. One couple more things when you're launching. Storage, we're just gonna stick to the default storage for now. You can set up tags, like if you have like hundreds of machines running, you can filter them to see which specific ones. Like I'll put a tag on all of mine saying this is my machine learning instance, so that way I can just like real quickly list out which ones I'm doing for machine learning.
Just want to mention, tags are important. If you're using the API, you're using automated chef scripts in the background to spin these things up. You want to make sure that you tag these things correctly so the chef knows what to go pull, because he's going to use the API to figure out this.
Yeah, absolutely.
It's very important if you do that.
Yeah, and we're actually going to have an example of that when I show you some of those recipe type stuff.
Tags in Azure.
No? Can you name your stuff?
Azure has a lot of issues.
Yes. Yes, you can.
Okay, so at least you can name them. Okay, so one thing too is the security group. You can create a new one, and this is where you open up your ports. So most of the time you at least want an SSH port if you're going to get to your instance. I'm going to use an existing group that I already set up, and you can. I'll show you in a second how you can change the settings for a security group. But you notice here I have the SSH opened up. I also have 6006 opened up for Tensor Board. So I'm opening up that web port because Tensor Board does not have any of my data on it. It's just kind of showing the status of my job. You don't want to open up any sort of port that's going to let you log in. Like when we make this Jupyter notebook, you do not want to open up your Jupyter port to the world, because then anybody can find your IP address and then get to your Jupyter notebook and start running some code. And that's why we actually have to create an SSH tunnel, which I'll show you in a minute. So now that we have our instance going, we have it connected up to the security group, we know we can SSH to it. We're going to review and launch. It's going to tell you all kinds of things about how your security is wrong, because it's pretty open at this point, but again, don't put any sensitive stuff on here. And then once you click launch, here is where if you don't have a key pair already, it's going to prompt you to create one. I already have one, so I already have this downloaded to my machine, so I know that I'm good to go, and I'm going to go ahead and launch this. I'm not going to click that button because I already launched one that's running in the background, because it does take around 5 minutes to get it all up and running, so I didn't want to have to sit here and wait for it. So once you do that, it'll download your PEM file, which is your key pair, onto your machine. Just make sure you don't lose that. If you do, you can just make a new one. It's not a huge deal. So that's kind of creating our instance. Let me go back. I did mention the security groups. What's nice about the security groups is you can actually modify them in flight. So if you go over here to security group, and if I launch my instance and I was like, oh crap, I forgot to open up my Tensor Board port, we can just go down here to the inbound ports and you can edit it. and handle it here. So back to my little dashboard. I have a running instance right now. So once you click that button to launch, it'll start running, and in the instance state here, it'll say that it's starting, and then once you see these status checks good to go, that's how you know you're ready to log on to your machine. So we can see some information about my machine. Some key stuff to look at here is your instance ID. Like when you're using the API, this is important to have around, because this is how you uniquely identify your instance. Like if you want to turn it off, if you want to check its status or whatever, that's your unique ID. Obviously the tags come in because you don't want to have to remember what all these IDs are and what they were to do certain things. If you just tag your instance saying I'm doing this for machine learning, now you can go list all your instance IDs for machine learning. Instance types are here. It tells you what availability zone you're in. And the key thing that we need is this public IP, or this public DNS name. So this is how you're going to log into your machine. So actually it has a handy copy button. So I'm going to copy this. I'm going to open up my handy dandy terminal window, and let me unfull screen here. Let me open up my terminal, make it bigger. Okay, can everybody see that? Okay, cool. Alright, so now that we got my public DNS name, we're going to use this command. So normally, the ssh-i command basically tells you use this PEM file to log on, and then normally you wouldn't need this little blurb here that has the port tunneling, but because we want to access the Jupyter Notebook, which is a web port, a web, web something, I can't think of the word.
Actually, I think two commands. One is log in and then spin off the Jupyter connection.
Yes, well actually, you could script this to do it both. For now, I'm going to just do them manually. This first one is, so I'm going to go ahead and type this in. I have my PEM file. I thought I had my PEM file here. Oh, I'm in the wrong directory. Let's clear that. So I have my PEM file, and you're always, when you log in, going to want to use the ec2-user. That's just the default user you use to log in, and then you put in your DNS name. So this is, again, this is just me logging in. I didn't set up the tunnel yet, but now you'll get your whatever connect. So now I'm on my instance, and now I can see that I am on a different IP. Okay, that's not working. Oh, here we go. Yeah. So now, see, that's my public IP address that I get versus my IP address on my computer. So I'm actually not on my computer anymore. I am on an Amazon instance. You can see all your hardware and everything. So see how I have, actually, I think it's top-M will give you more human. Yeah. So see, we've got 60 gigs of RAM, kind of ready to go. And I think the command to check your GPU is NVIDIA SMI, I think. And this will show you your GPU. So if you want to just open up a couple terminal windows just to keep status on what's going on with your machine. Yeah. So that $2,800 GPU, I'm paying 40 cents an hour for it. So I'm going to back out of this real fast because, again, we wanted to launch this SSH command with a tunnel also. So I want to do SSH-I login, but then I do want to do this -L, and basically what this is saying is take port 8000 from my instance, or the thing that I'm SSHing onto, and then map that to my local host 8000. So you could actually make these two different numbers if you want to, but I can never remember which side is my remote host and which side is my local host, so I just always use the same one so I don't forget. So what that's doing is basically making your port 8000 on your local machine go to the port 8000 on the instance. And then you could install a UI on it if you want to. I've never done it just because I've never needed to. But I'm sure there's a way to do it. There's also a visual way to get onto the terminal from the Amazon console. They have like a little Java applet where it'll take you on there. But you do have to install a desktop environment if you wanted to get that going. There might be AMIs around that have the desktop environment for you. But the goal of what we want to do is be able to kind of script this stuff so that way you can just launch an experiment, let it run for a week, and then come back to it later. And this is the most command line we'll have to do just for the Jupyter Notebook. So I'm going to launch in here. It's going to bring me into SSH, but now that port 8000 is opened up. So once I run this command, I run a Jupyter notebook. Make sure it's no browser because, again, we don't have a desktop installed on this machine. And I'm going to run it through port 8000. And this actually takes a little bit of time, and I meant to launch the notebook before I got in, but the traffic was horrible. So it took me 2.5 hours to get here from Boca, like, seriously. So just give this a second, and for now I'll go on the GitHub page and walk through the notebook until that launches. So, hey, thanks for the star. Okay. So under here, I have a couple notebooks that I'll kind of load up onto the instance, and I meant to do that. Uh-oh. Oh, I think I need 2 dashes. Nope. That's weird. I swear this worked for me before. Curse of the demo gods. Alright, so, okay, so this is going. So, I think by default the port is 8000. I must have messed up that port command. Let me check with this. See what this guy says. When in doubt, go to the internet. Okay. I launched it with the same command. Alright, anyway, this is launching. I'm just going to have to change my tunnel because I think it's going to port 8888 now. I think this should be working soon. Alright, so for now, I'm going to walk through one quick notebook because I'm not going to actually run through it live. But if you were here for the last meetup, I went through a quick example with some Medicare data, and that's what we're going to use today also. So for this fun experiment, oh, look, we got our notebook. Okay, so ignore this. I'm going to have to launch up another tunnel. I think, which one is on which side? Okay, so 8000, go into localhost 88, okay, so now I got my tunnel open. So for security reasons, what Jupyter does is it gives you this little token, and basically the first, I think it's like the first person who logs in, or if you log in with this, it'll let you go in. Otherwise, it won't let you go in. So like right now, if I go to localhost, and I just try to go to 8000, maybe this works. Nope, didn't work. Yeah, let me try 8888. Yeah. Well, that shouldn't work because it shouldn't be 888. It should be 8000.
Didn't you originally open the port to 6005?
That was a security group. So that was, I opened that up to anybody. So for this one, I'm tunneling to the instance. And actually what I'm going to do here is I'm going to shut this down. Yeah, I don't know what, that's something that's different. I don't know, that was working for me before. Let me see why this port. Yeah, right? This definitely. Right? Okay, let's try this again. Jupyter Notebook. Let's try putting the port command first. No browser. There you go. See, now that worked. Okay. So we should get this going. Aha! Okay. So now that let me in. If it didn't have that little token at the end of it, it would ask you to copy and paste the token into a little form on there. Alright, cool. So now we're here. Now this Jupyter Notebook is running on my EC2 instance. You can go make a new notebook in any sort of environment you want. I am going to upload a couple of notebooks that I've already pre-made. First one is just to talk about the data, and then we'll go into the let's see, we'll go into the Keras one. Okay, so this is just real quick on the data, just to get some background on what we're doing. So you notice that I launched this environment in just the plain old Python 3 environment because I'm just doing some Panda stuff here, data manipulation. I didn't need any sort of scikit-learn or Keras or anything. I did need to use SciPy, so if you're not familiar, if you put this exclamation point at the front of your Jupyter cell, it basically turns it into a terminal, a console. So I just ran this quick bash command to install it, import some of the packages I want, and then because I'm lazy, I'm just downloading it straight from S3 using the AWS command line interface. And this is from my public bucket, but if I didn't have the IAM role, I wouldn't be able to get to the private data. So what I'm doing here is just copying this S3 file onto my local directory. So like if you were to go in here and just do an ls, you can see that those are the files that I have. So let me go ahead and, this is a humongous file. I forgot about that. This is like a 2 gig file. So don't download this onto your laptop just to save me some money. But you see how quick this is? Like this is just going from S3 to EC2. It happens really fast. If you were to try to do this, over this Wi-Fi, it'd take a lot longer. So once I download that file, I'm going to load it into Pandas. It's a tab-separated file. Just some background on this. It's this particular data set is a Medicare Part B data set. So what Medicare does is every year they take all the claims that Medicare doctors have created and they aggregate it basically per procedure. So basically they give you a file saying, here's a doctor and here's every procedure they did and here's the amount of money they made off of it, here's the amount of money they tried to claim, here's the number of beneficiaries they have, the number of times they submitted the claim. And it's a really, really humongous data set because there's millions of doctors, lots of different procedures. And it's just a really nice publicly available data set to do some cool machine learning stuff on. And what's nice about it is that it's big, like it's pretty big. I mean, 2 gigs of the text file doesn't sound big, but it's humongous once you really try to do some kind of machine learning stuff into it. So
were you paying at this moment? It's just this data front end because you brought it to.
I paid a little bit for this to do the copy.
From one service to another one.
Yeah, so it went from S3 and now it downloaded it onto my EC2 instance. So if I go in here, like I think I'm logged in here still, I can see my files. It just downloaded this file here. Yeah, it's like you don't even have to think about it. The biggest cost is going to be the EC2 cost.
Fractions of a cent.
Yeah, per gig.
We've got, I think, in our company, 7 terabytes, and we pay less than $900 a month for it. It's just so cheap. S3 is like godsend of storage.
Yeah, I've had stuff on S3 for a couple months now, and my cost is still at 0.00 because it hasn't even gotten high enough to be anything. So a little bit background on this data is we've just got a doctor, and the key thing here is we've got this procedure code. So if you work in the medical space, this, or if you've gone to the doctor, you get back a claim form that says this is the thing that happened. So basically, you get this, and then you get the line service count saying here's the amount of times that this doctor submitted this claim in this particular year, and in this case it's 2015. They're usually a couple years behind. So those are the 2 data points that we're really going to use, is just the doctor. Oh, also their specialty. I think we have specialty in here somewhere. We'll see that in a second. So we can see here we've got, what's this, 9 million rows of doctor procedure combinations, so there's a lot of stuff going on here. And the provider type here is the specialty of the doctor, and that's really what our little toy example here is. Basically, we're going to take all of the claims that they make and we're going to see if we can predict what kind of doctor they are. Should be pretty straightforward. A dermatologist is only doing skin stuff, a radiologist is doing radiology stuff. But just some quick background data is, we've got, we got 1 million rows of radiologists. This doesn't necessarily mean there's 1 million radiologists, it just means there's 1 million doctor procedure pairs, right? And then all these other types of doctors. So what we're going to do, since it is a big long tail, just again for this toy example, just going to grab the top 10 provider types, and we filter that. We grab the things that we need. So the MPIs is the unique identifier for a doctor, their provider type, the code, and then their line service count. We're basically summing that because there could actually be a couple different rows for a particular procedure depending on if they're doing it in like a hospital or an outpatient setting. So now this is our little clean kind of long form data set. And when you run this, if you were to actually run, I can run this code. Hold on. I got my data already. So, oh, no I don't. Here. So it looks really simple. It sounds really easy, but if we start watching my resource usage, we're going to see that you will not be able to do this on your computer. So for now, we're still okay. It's got 60 gigs of RAM. It's only used 3 gigs. Takes a while to load in the file.
What are you trying to model on this thing? Like, is it the last what you were doing the last talk?
Same exact thing, yeah.
Okay.
So same exact problem. It's just a much bigger data set now.
Okay.
Yeah. So before, if you were here for the last one, we filtered this data set just to people in Miami. This one is actually the entire full data set, every doctor in the country. And this might take longer than I thought it would. But we can kind of run this stuff until we get there. So what this does is just creates a clean data set. But what we're doing is we actually want to take these codes for each doctor and try to predict their specialty. So we have to do a one-hot encoding. Basically create a new column now. So this is a long form table. We need to create a wide form and basically create a single column for every single unique procedure code. And then the value of that column will be the number of times they did that procedure. So did this finish? I think it did. All right, cool. So now we can see my memory usage is starting to go up. And we're going to run this data through here. Now, since we flipped it, we now have one unique row per doctor instead of one row per doctor procedure combination. Now we get 5 million doctors. And this is going to be the really intense operation. I'm going to start it now because probably won't finish until I'm done. But basically what we do is we pivot it. We say, I want each row to be indexed on the provider type of the doctor because that's my class label. And then the columns need to be now every single unique value of the procedure codes. And then the values in those columns are the number of times a doctor did that. And that creates a big sparse matrix, right? Because most doctors only do 10 to 30 codes, but there's going to be thousands and thousands of codes in our data set. So because of this, there's a lot of zeros. And when you multiply these two numbers together, whatever 500,000 is times 4,000, it's like billions of data points, and that's going to be like a lot of data to store. So now we're getting up to like 30 gigs of RAM being used. So if you try to do this at home on your computer, it would have blown up by now. But on the Ec2 instance, you don't even notice. Like the fan's not even running on this thing. So it's cool. So now this is what our data looks like. We've got an MPI here, we've got the provider type, and now we have all the columns for each of the codes that we're looking at. We just need to create a quick lookup file because Scikit and Keras like to deal with numbers. They don't really like to deal with actual strings. So we're just creating a lookup file saying that row number 1 and row number 0 is this type of doctor. We save that off. And then for kind of storage compression purposes, like I said, this is a really sparse matrix, so there's a ton of zeros. So SciPy, which is a scientific package in Python, lets you turn those matrices into sparse matrices because basically what it does is it stores the index and then the value of each row rather than storing every single individual column. Because otherwise, for most people, you'd have 4,000 zeros and then like three columns that had more than greater than 0. So if you only had 3 columns populated in a sparse format, you'd only have 6 values populated. So you'd have index 0 is this value, index 300 is this value, index 400 is this other value.
Do you guys run any, if it's like a sparse matrix, try to like say, I'm trying to think of the word, trying to put it in like triangular form so it's easier for computation?
Depending on what we're doing. Yeah, like if we're doing like a PCA or something like that,
like you reshuffle the rows just to get it like, everything down the diagonal. Because if it's like sparse, like randomized ones and zeros, if you could sort of like group it so it's diagonalized, it speeds up the computation. You do stuff like that.
Not explicitly. If SciPy does it, it'll do it because I know you have different types of there's different types of internal representations that it can do. So there's a few considerations to think about with sparse data. We're not going to really talk about it too much.
Yeah.
I'm only making it sparse just so we can save the file. When we pull it back out, we're actually going to make it dense again, just because it's easier. But if you look at this, in memory, that matrix is 16 gigs. But once I convert it to sparse now, it only has like, how many elements stored. Can I do this? See if it'll let me do it. Oh, actually, no, we can look on my S3. If we look on my S3 bucket, this file that we just made, the sparse is only 18 megabytes. So 18 megabytes versus 16 gigs. It really shows that you have a really, really sparse matrix. And then what you can do is just copy that stuff back to S3 because we're actually you would eventually shut down this instance, so you want to save your data in case something goes wrong. So yeah. Just kind of plop all your data there and you can do with it whatever you want to afterwards. Right, yeah, it just saves a little time. I mean, if you wanted to, it's actually you could just redo this every time, and it's not a huge deal, especially if you're scripting it. And, if you're running a deep learning model, it's going to take like hours and hours anyway, so it's not a huge deal to rerun this. But just for ease of use, and in case you wanted to download it locally, I just kind of made it sparse. What I really want to get to, though, is this Keras notebook. So I do have a little notebook example using scikit-learn as well, but it seems like you're only cool these days if you're doing deep learning, so I want to make sure I'm cool. There's a notebook here. 95% of all your machine learning cases are going to be able to be solved with like a random forest or a regression model. So don't get that wrong. Like, you definitely should be using scikit-learn. But this is just a quick random forest that I ran. It only took 3 minutes to run, and then we were able to get like a decent precision recall with it. And we can see our confusion matrix here. But again, you can go home and play with this stuff. It's all straightforward. You can run it, on your own instances. Walk through real quick a couple things that we want to think about when doing deep learning. Is, again, because that random forest only took me 3 minutes to get a comparable model, a deep learning model. It'd probably take me like 30 hours to train something, comparable to that. So just because of the nature of this data, it's not really the best data to do for deep learning. But again, we're all trying to be cool, right? So a couple things that you have to do before you put it into a deep learning model is you want to do some pre-processing on your data. You want to make sure that it's scaled and centered and zero mean and all that good stuff. And again, this talk isn't fully into like the cores of the machine learning. I really want to just show you guys how to be dangerous with EC2. But so if you want to dig into this more, we can chat later. So we just kind of scale our data. We remove anything with a zero variance, which means it's the same value in every row. We transform that, and then we need to convert our labels, our class labels, into numbers. So we just use pandas categories to do that. We split it up into a training set, a validation set, and a testing set. So with a neural network, you want a training and validation set, so that way every epoch you can see how your training is going. You validate it on the validation set, and then all the way at the end, when you're actually validating your model, is when you'll use the test set to really see how well your model does on unseen data. So we can see now, we split up our data into different sizes, and here's our network. So really pretty straightforward. This is just a feed-forward multi-layer perceptron, no crazy convolutions or recurrence in here for now. Couple layers. We start off, we're starting off with like 4,000 input nodes. First layer is going to have 500, then we go down to 100, down to 50, and then our output layer is obviously going to be whatever shape our output data is. In this case, I think we have, no, it says right here, we got 11. So we have 11 different classes that we're trying to predict, and 2 million parameters here. So actually, let me go ahead and run this stuff. I keep forgetting to do that. Should be pretty quick. Yeah, this is quick. Okay. So go ahead and run this and initialize my network.
You're running multiple times all at once. They're supposed to go in sequence.
They will go in sequence, yeah. You'll hit them and they'll all start off after the previous one is done. And so right now it's kind of splitting up the data. Then my training and testing split.
When you built this model, did you engage any of the multiprocessing of the GPU, or did you just leave it to the engine to take care of that?
This is the single GPU. So I'm using Keras just because I'm not a real expert on deep learning and I don't really know a lot of the internals of it. So since this is a single GPU instance, I've just used Keras to kind of abstract a lot of that stuff away. But if you do want to get into it, obviously you can get much better models if you kind of really tune it. Depending on your use case, Keras might be enough for you. This is still splitting, but anyway, eventually we're going to get down here, and this is how you launch Tensor Board. So again, if you do have a long-running neural network that's training for a long time, you want to be able to see the progress of it. Because if the loss just starts going up, it's like something's going wrong. You need to stop it and reassess what's going on. So it's nice to have Tensor Board, which is a nice web UI to kind of tell you how your network's going. And this is still running. Here we go. Okay, so this will launch Tensor Board. Oh, actually, I'm sorry, this will not launch Tensor Board. This will kind of initialize a Tensor Board callback, and then what you have to do is go into the console and actually launch Tensor Board yourself. So What this enables, and we'll run through this generator for now. So this is my model, and basically I'm putting the callback here, saying use Tensor Board as a callback. I'll come back to this generator in a second. So now that's saying basically write to that directory that I said, write my logs to temp/tensorboard. So if I go in here and I run that command that I thought I copied, okay, I'm going to type the command. I'm not going to do anything. That's weird. Alright, let's try going in again. Here we go. Alright. I just freaked it out. Must be the internet. Alright, here we go. So this is saying launch the actual Tensor Board service. Oh, right. You have to actually activate the Python environment. So I have to do... Yep. Oh, thank you. I do that every single time I type that command. I don't know what it is. Okay. So now this actually launches the TensorFlow, and this will launch TensorBoard, which very similar to the Jupyter Notebook. It's just running a background service in the terminal, and now this is running on my instance at 6006. So this is that port that we opened up. We don't have to open a tunnel for this because we set the security group to basically open this up to the world. So if you wanted to, you could actually now go grab this IP address and go look at my Tensor Board if you wanted to. But you don't want to do that, right? You don't really care. And now this is Tensor Board. So an epoch hasn't finished yet, so nothing's going to show up quite yet. But once you start, it'll start showing you some nice pretty graphs about how your loss functions are going and things like that.
So what are you looking on that board as the calculations are going through? Are you looking for what? As your monitor, what are you looking for in your monitor?
Really, the only thing that I use Tensor Board right now, and you could go add other metrics if you wanted to. Here's a cool little visualization if you want to look like you really know what you're doing, is show somebody this. Like, this is the model that I made. Look at this cool neural network. I have no idea what this means. Okay, so now I've got an epoch running. So really, the things that we care about right here are this loss and the accuracy. And those are the two things that, after this first epoch finishes, we'll be able to see it on the graph, is you want to track that. Because basically what should be happening every step in training a model is that your loss should go lower and lower because your network is using more and more data and is learning more and more relationships about the input data and how it relates to the output. So if your loss just like starts to go up, like that's a problem. And what's nice about Tensor Board is if you did have other metrics or other things you wanted to track, you could use the API to go add some other stuff in there. I haven't done it myself. And so now if I refresh this...
So you're saying the loss is convex then?
Yeah, I don't know if there's a global minimum necessarily, but there's some sort of minimum that you'll get to, that you should get to.
Right.
If it goes, sometimes it might just go straight up and something's wrong with something's wrong with your network. So this is our first little point. So my loss is at, let's see, my accuracy is at 2.25, which is terrible, and my loss is at 2. So, hopefully this accuracy should start going up, and then this loss should start going down as time goes on. So that's just a fun little thing just to watch your network. So now you can launch this network. You can go, have dinner, go to bed, come back in the morning, and kind of see where your model is. That's pretty much everything you need if you wanted to just go tinker around and go into doing this kind of by hand and playing around with it. I wouldn't advise running a long-running neural network in a Jupyter Notebook. It's just really not the right environment for it because you might accidentally hit stop or something might happen. The way I do it is I actually launch the instance from the command line, and then I send a command to the instance to run kind of on its own. So I'll run it as a background process, and then it'll start running. And so that's a perfect segue onto the next point of conversation. So any questions on just all this stuff? I know I kind of threw a lot at you, and hopefully all the EC2 concepts kind of go away now that you can see the fun network happening.
So you are doing this on a bunch of data that you already have. So what about the continuous input of data? Like a software end user sending you data, or I don't know, a sensor sending you data?
You can totally do that, and that's really just up to coding the model properly. Actually, this generator. So Keras, when you fit a model to Keras, you can give it an entire data set. It's like if you have a big matrix or an array that has all your data points in it, if you're doing a batch training. But what you can actually do also is use this fit generator method. And if you did have live data coming in, you basically just need to give a function that yields data for every batch. So you can, as data comes in, you'll get a new batch and chunk of data, maybe like 100 instances. Then you can pipe that in, and you can train the model on it. There's a lot of stuff you have to consider when you're doing online training. I haven't done a lot myself with it, but you can absolutely do that.
How would you set up the machine? Like, how does the machine take those inputs?
Oh, like the actual instance on Amazon. There's a lot of options there. You would probably, honestly, if you're going to do that, you'd probably want to use a different service, I think, than EC2, unless you really want to wire up everything yourself. You can use something like Amazon Kinesis, which is a streaming platform, or something like even Apache Spark has some good live model training stuff. But you would have to basically just go in here, open up ports, and set up things and connect them all together. All right, so we've got about half an hour, so I'm going to jump over to another thing. Well, I'll just leave this running. Why not? Just spend my money. So this first part was just getting our feet wet, jumping in, launching an instance, being able to play around with a notebook and get some code going. So now hopefully you should be able to take this, go and do whatever you need to on Amazon. But what I do, mostly for my research, is that I need to run long-running experiments. I have I want to try 70 different parameters, and I have 10 different data sets, and I need to be able to run all those experiments, save the results somewhere, and then come back to them and analyze it. For a lot of things that you're doing in industry, you might only need one model, just run a quick grid search, and you don't really care what every single parameter combination does, is you just want the best one. But if you are really trying to experiment, if you're coming up with a new algorithm or something, you want to be able to save all your results. And that's really where this fun little package that I've been working on does that for you. So there's a couple other setup things that you have to consider. Is everything we did just now is we launched the instance from the Amazon console online, and then I was just able to SSH onto it. But if I want to just hit a button on my computer and then let it run, we need to set up a couple more things, and this is where users come in. So when you log into your Amazon console, you are the root user, and you can do whatever you need to. If you're going to run something from your local machine and you want to give your computer permissions to launch an EC2 instance, you want to create a new user to do that, because you don't want to just store your password around in random different places. So to do that, we have to install the AWS command line, which is a super quick pip install. We need to do a little bit with users, so let me jump back into the IAM. And I did not have the time to kind of walk through this in my head, so I might be bouncing around a little bit, so I apologize. So here's where you would add a new user. So again, you can think about this as a person. So now this is a user that's going to set up their credentials on their computer and now try to do stuff with my Amazon account themselves. So I add a new user, and in this particular case, I just created a group with certain permissions in case I needed multiple users. So what we really care about here is that the policies that I want this user to have is I want this user to have full access to S3, which means they can create files, put files up, do whatever you need to. They want EC2 full access, which means I can spin up a machine, just like I did from the GUI. I'm going to be doing this from the command line and from an API. This last one, which is called a pass role, is basically, it's a little convoluted. It's basically saying, since you need to assign the IAM role to the EC2 instance to get S3 access, your user actually has to have permission to give that EC2 instance that permission. So we're saying that this role is allowing my user to assign an IAM role to an EC2 instance. So now that EC2 instance has the IAM role and can access S3. So the way you do that is just attach this policy, and then I think you can add like a custom one and pop in that that JSON. I think, yeah. And I kind of put that here, and then I put a link to that. Like if you really want to read up on it, that's down here. Okay, then last step is to configure your credentials. So you want to set when you configure your credentials, this nice little Amazon AWS configure command. I'm not going to run it because I've already set it up on my machine. But when you run this, it basically prompts you to put in your, let me show you the access key. It'll put in your access key. You get an access key, which is basically like a username ID. You get a secret, which is basically the password. And then you got to set up your availability zone. So when you create your user now has something. Yeah, access key. So when you create that user, it'll prompt you to download a CSV with your access key and your password. And then you can just copy and paste those when you run the AWS configure. So what that does is it actually puts in a couple files in your root directory under AWS. It creates a config file, and then it creates a credentials file. So your credentials file is going to store that access key and the password, and then your config file stores which availability zone you're in. And again, I'm running through this really fast. When you go do this later, click on these links and it'll kind of run you through that. And then a nice little tool that I like to use is Cyberduck, which is just a file browser. It can connect to all different types of file systems. It's really the only one that I can find, at least for Mac, for S3, if anybody has any better ones, because it's a little buggy sometimes. But this is just nice because you don't have to deal with the web UI. You can just download and kind of put data up and back to S3 from this GUI. Just because you can just double click it and it'll download the data, and you can just drop data files onto here without having to deal with the UI on Amazon. And the way you would do that is if you open up a connection, you can go in here, click S3, you'll put in your access key, and then you can put in your secret key, and then you'll have access to your data. And so once you set up those credentials locally, you can now do stuff like list your bucket. So I'm going to do, there's a whole bunch of commands that you just Google AWS CLI commands and you can see it. So I'm just going to say AWS S3, I'm going to do an ls on my bucket. Oh, and I have the wrong profile, so yeah. So now you can see that my bucket has these files, which correspond to these files that I have here. I'm sorry, I don't think I can make this window bigger, but the Cyberduck window. So next step is more code. So this it's gonna get real heavy now. So I'm gonna run through this, and if you have a question, let me know. And I'm not going to spend too much time on this if you want to tinker around with yourself. I just want to be able to show it to show that you can actually kind of operationalize this kind of stuff. So I have the code. I have this loaded up in PyCharm. So basically, the starting point here is, I think I can zoom in. All right, okay. So we're using a package called Bodo3. And so rather than using the actual AWS command line interface that, where you just type in some bash commands, this Bodo3 interface is an exact mirror of the AWS command line interface, except it's a Python API. So now you can write Python code, all the responses come back as dictionaries, you have nice objects that you can deal with, and it just makes it really easy. So this particular script is a script that I wrote that basically takes in a couple components. So if we go down here and look at the arguments, this script, what this does is it will launch an EC2 instance for you. It will run whatever script you want it to run, which will have like your scikit models in it, your Keras models in it, whatever you want to do. It's just a Python script. And then it'll basically spin up the EC2 instance. It'll send the script to that instance, kick it off, and then it'll detach. So you just have to wait a couple minutes for the instance to come on. It'll launch it, start running some stuff on their EC2 instance, and then it just disappears. So you don't have to keep a Jupyter notebook up running. You can close your laptop. You can do whatever you need to and then come back to it later. And what's nice about this is when you use the Bodo3 API, you can now start saving all your files onto S3. So you pull your data off of S3, you save it on there, and then you can do whatever you need to. So this package that I wrote is basically just a couple helper scripts to help you do that. And I'm not going to dive in too much to the code, but this is a good example of how you create an instance. So I'm saying I'm going to use my EC2 service. I'm going to run an instance with this AMI. The instance type is a parameter. I'm going to use this role, and then I'm going to use a spot price. And so what's cool is that you can now parameterize all these things and just run off a quick experiment. And then what happens here is that I have a lot of code that basically checkpoints and saves all of your information onto S3. So something blows up in your experiment, the instance dies, or the spot instance gets terminated. You're basically checkpointing every single thing that you're doing onto S3. So the starting point here is actually, I can run this. So we can run all this stuff. So that's a Keras. In Keras, that was the basically after every epoch, it'll save the model state as is, and we're going to save it to S3. So in case the EC2 instance blows up, we can pick it back up where it left off.
What's that? Just a JSON file?
It's an H5. It's an HTF5 file, which is basically just storing all the weights, so all the numbers for the weights. Yeah, I'm running through this. I'll show you all of it in S3. This is really cool. So this is just some stuff to operationalize it. But I get my S3 resource, and then down here I think I get an EC2 somewhere. EC2. And so what I'm going to do is I'm just going to hard code some of these parameters. But this is all stuff that would be parameterized from the command line. But I'm just going to do an M4 large. My key name. Depends on what you're doing, but usually it's one file per epoch. I did 50, however many you want to do.
In real life?
In real life, you'd probably do somewhere around 50 to 100. Unless your loss just stalls. So if your loss just keeps going flat, you can stop it early and then just take the 20th epoch or something like that. And I'll set my bid price equals this. I really just want to show, and then I set up my tag. So here, the key we were talking about with tags is that I'm basically tagging all my instances as I'm saying my app that I'm running is machine learning. So when I list it later, I get it. So here is now your create command. So you run this. Okay, try to run this. Oh, it's because it's indented.
Are you able to kick off from the epoch stage?
Yes, you can. I don't have any code right now to do that because I hadn't need to. But yes, and that's the exact point with it. It's like if you have a spot instance and you get through like 30 and it shuts down, you want to come back to it, you can start it off from epoch 30 instead of having to retrain your model all the way. So now under this create object, oh, okay, this might not work. Alright, we're going to skip that for now. You guys can play with this later. But basically what this code does is it gets the instance ID from that response. It's a JSON response. Waits for the instance to get launched. And then it'll give you the public IP address, which is the DNS name. And then it just like saves all this information onto S3. So what I do is I save it every time I launch an experiment. I save up a JSON file. And so now I have a log of all the experiments that I've run here. So if I wanted to go in here, if I launch it and then my terminal goes away and I lost all those messages, I can go in here now and see all this data. So now if I wanted to go into that instance, I now have the public DNS name. I have a couple of just handy things that I do to help myself. And then really the key of what happens here is that once the instance gets spun up, we send a script to it, tell it to run this Python script, and then now my experiment's running. And now basically I have a little folder here that checkpoints all of my models. So this is one experiment that I ran. I just gave it this little UUID. So now this is epoch 1, epoch 2, whatever. And you can see the timestamps as it took to train. And then I save another folder of stuff that basically saves the results of that. So this CSV here, oh, I already downloaded it. So this CSV here has a log of my run. So now this shows a row for every epoch, what the loss was, what the accuracy was, and whatever. And so what I'll do is then pull this into R and then create some graphs and some analysis on that. If you want to dive into the GitHub, and there's a bunch of code here to play with it. And if you find it useful, let me know. If you don't, that's cool too. So that's a quick run on just running it kind of more operationalized way. Yeah. Yeah, I mean, yeah, pretty much. Like a lot of, I mean, some of the code, like the reason I've had to do it this way, I probably, if it was just my own experiments, I probably would just run a notebook. Because of some of the limitations I have at work, I have to actually do everything from the command line because we don't have console access. So they give us specific keys that we're allowed to use and specific permissions, so we're able to now just use these APIs to launch them up. So Google is obviously your best friend with this, is just Googling what the APIs do and everything. Yes.
If he's willing to share it.
Yes, absolutely. So it's actually all already up. If you go to, if you go here, actually, I already put all this up. So it's public GitHub. I put all these examples in here. I even put the PDF of the slides up here, if you want to get to it. Yeah, sure. I'll post this up on the meetup page afterwards too, so make sure everybody's got access to it. I can post it in the Slack too. No, it doesn't. Yeah, so so that, yeah, those aren't on there. And okay, so that's pretty much it. So a couple resources, just extra stuff I didn't have time to get to. I wanted to talk about. If you want a good intro article just for AWS, couple cool things like I was talking about, some of those serverless packages. SageMaker is basically Amazon's like machine learning in a box. And AWS Lambda and Pyren are basically like serverless Python code where you can run a bunch of stuff. But I've been talking for long enough. So any other questions? Anything?